commissioning the solar suitcase. Now that it's been assembled, we want to commission it to make sure that it's properly wired, that all the connections are tight, that there's no damaged insulation, and that all the sockets are actually placed in the right orientation. To do the commissioning, you'll go step by step with the student assembly and commissioning guide. I'll just show you a partial part of the commissioning so that you get a sense for how it's done, but I'm not going to walk you through every step. So first of all, we would do a visual inspection. We want to make sure that the sockets are properly oriented. That means that the writing on the socket is on the top of the socket, and these all are. We want to make sure the socket is fully inserted and that the cover material is not holding it up at all. And these are nice and flat against the control board. We want to make sure that the switches are properly oriented. So this is the off position with the circle, and the on position with the line is on this side of the solar suitcase. If you're facing it, it would be to your right. And these are all properly done, and this one has the on position facing upward, which is correct. We want to make sure that the battery type selector is set on 2 for a sealed battery, and this is properly set. If not, you'd use a small screwdriver to set it to 2 if it was on 1, for example. And we want to make sure that the solar socket is properly oriented. And you can see this is where the larger writing is, facing the top of the control board. So this all looks very good. Next, we want to check the tightness of the screws on the charge controller. So we put the screwdriver to the small slotted tip, and we want to make this really tight. So we go ahead and give it a good hard turn. This charge controller can handle very tight screws. Don't totally muscle it, but make it really tight. That one needs a little bit. This one needs just a slight turn. That's good. That's good. Okay, now we're going to flip it over and do a visual inspection of the connections to make sure they're done properly as well. So I'm looking to see the negatives on the outside edge of the sockets, and you can see these white wires. The negative wires are to the outside edge. The positive are more toward the center. So these all look good, and these all look good. I want to make sure that they're fully set on the tabs, and you can see that these are fully set so that there's a good connection and it's not going to fall off. And then I'm going to trace the battery and the solar circuit. So you can see the solar comes in at the bottom of the socket here, or toward the top of the control board, goes into the breaker and then to the solar positive port. And the battery is coming into the breaker and goes to the battery positive port. So this all looks good. And then I want to make sure that the screws holding the charge controller onto the board are reasonably tight. Now we don't want to super tighten these because the housing is plastic. So we go ahead and put in the Phillips head tip, and we just give it a little bit of a turn. This needed a little bit right there. And this one needed a little bit too. We want to make it tight, just not super tight because we don't want to crack the plastic here. Snug, snug, good. It's nice also to make sure that the circuit breaker is fully inserted and not falling out. If it is, just pull it in and it will snap into place or click into place. And we want to see that the wires are properly managed so that they won't get pinched when somebody puts in a battery. So these zip ties are really done well. And then we want to take a look at the terminal blocks and make sure that they really inserted the wire fully. And you can do that by looking at the window, and you'll see in the case of the positive wires that you can see blue insulation going most of the way into the purple space on this connector. And you can see the white wires going most of the way, white insulation into the purple space of this connector. So these are all in a good 1/4 inch or more, which is excellent. And we can say they also did a good job looking through the window on this terminal block here. So everything here looks really good. Now it's time to just flip it over. Oh, one more thing actually. That is, we want to make sure that the nuts are tight. So this is a 3/8 inch wrench. And we just check to make sure that the nuts holding the straps down are good and firm. These are. And the nuts holding the solar socket are also good and firm. So this could use just a little bit of board tightening. And they actually did a very nice job on this on this main control board. It looks really neatly done. Everything goes quite tight. I'm very happy with it. Okay, so we're going to set the multimeter to continuity. And the way you can make sure is that you can put the two probes together and it will ring. Great. And now we're going to move systematically through the solar suitcase to make sure that all the connections are right. I'm not going to do this step by step because it's in the assembly guide, but I'll give you a few examples. This is battery positive, and if I put this to battery positive on the charge controller, it won't ring unless the main switch is on. And then it should go ahead and give us a nice beep. There we go. And on the negatives, this is a really nice chance to teach your students that all the negatives are bonded together in a system and they do not go through the circuit breaker. So even with all the switches off, we'll go to the battery negative and we can just go through the solar negative, battery negative, load negative, and the sides of the sockets are also negative, so we can test those. And you can see that they are all bonded together. There's even the negative on the expansion port, which is the inner one, and that's bonded too. That's good. And we can even plug in the home run cable and check out the solar negative, which would be the black wire. So if we take the black wire and hold it here and then touch it to solar negative, we'll also get a nice negative ringing telling us that all this wiring is very good. So our negatives are in good shape, and then the positives we can test both with the circuit breaker on, which would give us a beep, and with the circuit breaker off. I'll just do a couple with the circuit breaker on so you can see it. So this will give us battery positive. Let's go to solar positive, and we can go to load positive, which will be at the bottom of the socket here. Oh, with the switch on. Whoops. Okay, now the switch is on. Just testing you. And then we can check load positive. I'm going to take this off. Load positive between the load positive here and the expansion port. That's good. Now, just to make sure there are no short circuits, with all the breakers on, we can make sure that you don't get a connection or continuity between positive and negative. If you did that, there would be a real problem here. So I systematically would go through here and check all the positives and negatives, and if there's no ringing there, I'm also very happy. So just for fun, you could have a student hold these two wires together, which would be like a short circuit from the home run cable, and then they could touch the positive and negative, and they'd see that positive and negative are touching. That would show us short, but you can see if they're not touching, when there's not a short circuit, there's no continuity here. So we never want to see that, but if there was damage to the wires, you could actually have that in the field, and that could create a short circuit hazard.